Okay, everyone. While I'm away, we'll begin or have you begin topic 7, uh, which is plumber and toilet installation. So this topic and our notes are here. Okay, so students will be expected to. So we have 6 objectives here. We'll go through the first 2 here. So demonstrate safe practice for use of hand and power tools common in toilet installation procedure. And next objective, identify, describe, and give the function of the components of residential water supply system for a toilet. So the first one. So here we are. Plumbing, like most specialized trades, employs specialized tools. They're used to cut, shape, and fit pipe and fittings in the plumbing phase of residential construction. The activity for this section will be carried out during the activities in remaining plumbing topics and specific curriculum outcomes. Most of the plumbing tools are basic in terms of their operating requirements and can be demonstrated quickly, which we'll go over when we're in the shop. However, do not assume ever that because they're simple, that you automatically know how to use them, or I won't assume that, and that there's no safety requirements. Like with any tools, there's always things to keep in mind from a safety perspective. So plumbing tools are designed for specific tasks. Using the wrong tool can often damage plumbing parts, which can be an expensive mistake. So as always, use the right tool for the job. Some tools are intended to be used in a specific way. Adjustable wrenches, for example, are intended to be torqued in one direction, and I'll show you those when we go out there, and will eventually be damaged if used incorrectly. Safe practices must be observed at all times, and will also demonstrate the operation of tools in the student activity. So, student expectations: identify each plumbing tool that will be used and become familiar with the use and operation of that tool, and create a suitable work entry in your log. So you should be doing that. Next objective, identify, describe, and give the function, the components of residential water supply system for a toilet. So the supply side of plumbing system begins with cold water source from a well or municipal water supply. So we always start with where the water comes into the home and even how it gets into the home. The supply line is usually pressurized, which can be from a 3/4 inch, 1.9 centimeter, to a 1.5 inch or 3.8 centimeters diameter pipe. So in other words, go to where your water comes into your home and look at the size of the pipe coming in. Most of you are going to have a 3/4 inch line. However, larger homes or businesses can have a larger water supply. So everyone viewing this would probably have municipal water, so you're getting your water from the town, either Grand Bank or Fortune. The size of the pipe is reduced for distribution in the house. So when the pipe comes into the house, its diameter gets smaller. So there's a way to reduce that. The first branch is to the hot water heater, and then 2 parallel branches of hot and cold water supply are run to appliances in the house. So we'll go through that in the diagram there. The toilet supply is a single pipe and is only cold water, so we don't bring hot water to our toilet. Something similar to think about would be now a lot of fridges have ice makers built in, and they're only going to have a cold water supply. So this is one of the few instances in residential plumbing that a single supply pipe is used. So if you think like a toilet and also a fridge with an ice maker. And I'll just make this bigger here. So supply systems may be installed with branch circuits, so it can be in series. So if we look here at this diagram, we have in series would mean each connection one after the other. So if we follow this, we would have our cold water would be represented with a black solid line. So if you follow the direction coming up. Here from the bottom left, cold water comes into the home, goes first to the water tank. Hot water would then leave the home and then go out to our different fixtures, or not leave the home, sorry, leave the water tank. So you bring hot water, say, to a sink, perhaps another sink, so one in the basement, one upstairs, or it could be one in your bathroom, one in your kitchen. You could also bring it to a nozzle inside the home. Sorry, not the hot water, but your tub. And if we follow the solid line, again, cold water's coming in. And then also, so you'll branch off here at a T, so you have a T shape. And the only area you're branching off there, but then you branch off going to each of the appliances. So a sink, a toilet, your dishwasher, they're all called appliances. So you bring cold water to each of those. This is called in series because you have one following the next. You don't have any branches coming off this. The pipes aren't going in different directions. There is one cold water pipe going through the home here. And then you have branches coming off of that pipe. And the same with the hot water. You can then have parallel distribution. So your parallel distribution would be shown here like this. So you would have your cold water again coming in from an outside source, coming to your tank, but the cold water is also branching off at different points. So this is not one T, and these are not connected one after the other. But here, if you follow, it looks a bit much, looks like a real busy diagram there. But if you just follow one line at a time, so cold water is going to this first appliance, could be a sink, perhaps in your kitchen, another sink here in the middle there, perhaps that's in your bathroom, and then could be going to perhaps a shower. And your hot water is doing the same. One of the disadvantages of this type of system doing parallel is that it's a lot of piping that's used. So this would require a lot more pipe and will be more expensive in most cases. Now if we just look at the picture here, you could have a combination of both. And this is what you'll see in most homes. So you would have your water supply, if I look down here at the bottom of the diagram, your water supply coming in. Your water supply coming in can go to your washer. So this would be a clothes washer. Perhaps it's going to another appliance over here. And then over here to your hot water tank. Your cold water is also branching off then. So these will be in series. So coming off, you have your dishwasher, perhaps you got a sink in your laundry room there. And then it's going upstairs to a toilet, going upstairs to a sink, and then you got a sink up in the kitchen, and going here up to perhaps a dishwasher. So as they follow along, they're going in in series. But if you look at your hot water will be in parallel. You have two different runs. So cold water comes in, gets heated up, and goes here to your your clothes washer. And they can go up to your sink, and it can also go up to a sink here. So here's where the parallel part comes in. Is that you now have two different runs coming through. So one main line for hot water, and then it makes two branches off. So these are in parallel. But as you go through parallel, say to a bathtub, a shower, sink, and toilet, each of these are in series. And if you notice to a toilet, as we said, you don't have hot water going to your toilet. So most of you, if you have to redo your pipes in your home, take notice how that's done. Or if you're able to see the pipes in your basement, look at the ceiling and follow how they're running. It's fairly easy to tell which ones are for hot water and cold. One is coming from a hot water tank, but if you put your hand on it, it's going to feel warm if you have any flow of water through the home. The manner of distribution, so how the water is distributed will affect the pressure, the rate of flow, how long it takes for hot water to reach a particular appliance, and the ideal water flow is to have shorter paths. So you want to have a good pressure in your home, you want to have a good flow of water coming out of each appliance, and you don't want your hot water tank. I probably wouldn't have my hot water tank as it's shown here in the diagram. However, if I think about my own home, perhaps some of yours will be the same. My hot water tank is on one end of the house, and it has to make some long runs. So it has to go from one house, say, to upstairs and over to a bathroom, perhaps off the bedroom. That's quite a bit of run. So all this pipe is filled with hot water. If you think about that, that hot water is going to cool over time, and it's wasted. More ideally, you'd like to have the hot water tank centrally located in the house, so it's less piping runs have to be made, so your hot water stays. You don't have to run as much hot water, and you're not wasting it. If you're wondering how much water can get held up in a pipe, we'll demonstrate that in the lab. But if you ever have to cut a hot water or cold water pipe in your home, you'll lose several gallons of water. It can be quite a bit of water that comes out, more than what you realize. So the water supply in a house is a managed pressure system, so it has to be under pressure. So if you cut or puncture one of those pipes, you'll find it very quickly how much pressure is in that. And it has to be in order to drive water through the home. And not only driving water in your home, but the water lines going through your town are pressurized because it has to deliver to your house, your neighbor's house, and right on down the street throughout the entire town. Pipe sizing is used to control pressure distribution through a house. Most homes now, newer homes being built, are going to be built with 3/4 inch pipe going through the main part of the house. So if we look back up to this diagram, the main lines traveling through the house will be 3/4 inches, not a half inch. That difference in size means that if someone's having a shower and you flush a toilet, they don't lose water pressure because there's enough water going through the pipes in the house. If you're wondering if that happens, well, wait till next time. Turn the shower on your house and flush the toilet. Or when the washer kicks in, if you turn on the washer and then you lose water pressure going to a sink or your shower or toilet. Now, means of controlling water in the house, where it's going, will be done through valves. So we can have ball valves, and these will be quarter turn. So a quarter turn means you only make a quarter of a circle. So if you grab the handle, you don't go all the way around. You're only turning 90 degrees. That's a ball valve. A gate valve, you're screwing it in or out. So in will be closing off the water, and turning it out, turning to the left will be opening it. So righty-tighty, lefty-loosey. And most of us have these for our water spigots inside our home. Washing machine, very similar. So hot and cold water. Red represents hot, blue cold, but don't always assume that to be true. Sometimes someone may just simply run out of one type of valve, and you could see two red or two blue, or they might not be color-coded at all. You also have valves underneath your sink. So if you go home and look underneath your sink, or even at the school, you'll see shut-off valves just as the water comes out, and then there will be a hose connecting up to the taps. Behind your toilet, you also have a shut-off valve. Again, just one line coming in. It's one of those appliances that we mentioned earlier. It's only going to have one line in. So this would shut off the water going to the toilet. Again, another example of that would be refrigerators that have built-in ice makers. Your water heater, you don't often think about it, but when it's not working, you'll think about it. So we have electric water heaters here in the province. We don't run by gas. We don't have natural gas sources here. But if you go to the mainland, particularly Alberta, Saskatchewan, Ontario, it's going to be very common to see a gas line coming into your house. And what we mean by gas is not gasoline, but natural gas. And those would have a pilot light. They actually have a flame that would heat the water. But in this case here, we have two electrical elements, like I showed you in class. So one on top, one on bottom. And these are controlled, if you come over to the diagram here, they're controlled in particular ways. So if I just zoom in here, Bear with me for a moment. So you would bring cold water in. So here's a ball valve. So it's a quarter turn. So water comes in, fills your tank, and different levels of the tank can fill at different times. So one heater is going to kick in first, and then usually the second one, because it's water. You're going to heat up the bottom one. That warm water is going to rise, and then it doesn't take as much to warm the top. So your tank is actually pretty complicated when you look at it. You also have hot water coming out. So we have water coming in, water leaving. So if you want to get someone out of the shower really fast, turn off this valve right here. Don't tell them I told you, but you could do that. Now also with these electrical tanks, you'll have a wire connection here. Now we don't get into wiring the tank itself, just that what I want you to know is that you'd have 220 volts coming in here, not the regular 110. So you were working with 110 when you were doing your three-way switch hookups. This is going to be on a double breaker. So when you look at your circuit panel or breaker panel in your house, it's going to be on double one and runs 220. So it takes a lot of electricity. That's why parents get mad at you sometimes when you drain the hot water tank, because it uses so much electricity to heat it up. So those are two heating elements. Now, anything can malfunction. If let's say you have a heating element that doesn't shut off, because these are controlled by thermostats. So if it doesn't shut off, you'll get your water overheating, which is going to create steam. So just look on the side of your tank when you're home, either on the top or on the side, and there's going to be what's called a blow-off valve or pressure release valve. So that valve is meant that when the pressure inside the tank reaches a certain level, this valve should open up and then let the steam and hot water come out so it doesn't explode the tank. An exploding hot water tank can damage, if it's in your laundry room, you can blow it off quite easily. You can also drain the tank if you need be. So your tank should be drained. A suggestion would probably be yearly, but I would talk to a plumber, because sediment and soil will come into your home. Think outside the home. If the town is working on a water pipe, well, as they're replacing sections of the pipe, there's going to be dirt get into that line. And even from water supplies, you can get dirt and sediment come in. Well, all that sediment will settle in the bottom of your tank, and it can corrode your tank, and it can coat your heating elements. So it's a good idea to flush your tank, and there's a method to do that. What you're seeing more and more now are tankless water heaters. So this is an example of someone using natural gas to do it. So the black pipe here is a gas pipe. Again, you could have this in your home. You just need to have propane tanks inside your home. And you could have this is an on-demand or tankless. So as you require hot water in your house, water's going to get heated up fairly quickly. So would light a flame, that's going to heat up the water really quickly. So there's no tank to store water. These can also work by electricity. They just consume large amounts of electricity when they work. But they are possible, and they are becoming more common. All right. Well, we're also talking about controlling water into a home. We need to have a discussion on water hammer. So water hammer happens, let's take a look here. So you have a valve, and as water's flowing through here, it's stopped by the valve. You open up the valve and water's able to move through. If you close the valve rapidly, the water stops suddenly. And water stopping suddenly doesn't react well. It causes back pressure. Water collides. So just think when you get fill up your bathtub or halfway fill your bathtub, and perhaps you've done this when you were kids. You scratched something near the front and kicked off with your feet and force yourself back. Well, you're creating essentially a tidal wave, a water hammer. So as water is flowing, it wants to keep moving. If you stop it suddenly, then it backpiles and it creates a lot of pressure, and you can bust pipes. So one way around that is that in a water pipe, you can see this thing called water hammer, arrestor. Arrestor just means to stop. So this is one means of doing it. It's not the only way. So if someone were to shut water off fairly quickly here at the valve, the water backflows, it pushes back. Then all you've done, essentially, all this is really is just a section of pipe added to allow the water to force to go up. It gives water an escape path, so it doesn't go back through the main line. So since there's a piston here, so there's just a little, piston, a cylinder that goes up and down inside. So it takes the energy from the water hammer, it pushes that up, and there's air inside here. So the water compresses the air, doesn't go all the way to the top. So air stops the water from going all the way to the top. So it's like a shock absorber. It acts like a spring. Air can act like a spring. An air shock, if you think about those with cars. So it takes the energy out of it. So just the last part here. Water rule. Two types of water supplies. You have rule or water main wells. So a rural water supply. So rural communities such as Grand Bank and Fortune obtain water from both surface and groundwater. Most farm and ranch families depend on groundwater. Increasingly, rural residents are able to take advantage of expanding rural pipeline systems that service small communities and individual farms and ranches. Okay, so think about if you were living in Grand Bank. Okay, you don't think of it so much. You have a main water system, or a Fortune. But if you had a cabin, or you lived down at Moyers or Krause, you're probably going to be on a well system there. Now, if the water lines from the town extend out far enough, you may be able to tap into that. But you're not going to see the water lines from our towns go those large distances. Water supplies from groundwater can be accessed either through wells or springs. The majority of the rural population relies on water wells. So still plenty of the communities in the province that rely on water wells. They don't have a central water system. So just because you have it, or we have it, don't think that everyone else has it. So a water main or a well, types of wells. There are 4 common types of wells. So you can have a dug well. Now, historically, these are done by hand shovel to just below the water table. So until incoming water exceeded the digger's bailing rate. In other words, you dig down until you strike water, and you stop digging when more water comes in, then you can get dirt out. So as it starts to flood the hole. So these are usually lined with stones or bricks, tile, or other material to prevent collapse. So again, thinking more common of a cabin. Usually capped with wood, stone, or concrete. So on the top, you'd cap it off. And because of the type of construction, bored wells can go deeper. We'll talk about bored wells. But these hand-dug wells can only go so deep. And these wells are able to obtain water from less permeable materials such as fine sand, silt, or clay. So in other words, when it rains, the rainwater is going to go down through the dirt, the sand, the silt, and the clay. And that would actually clean the water, believe it or not. And then the water is just able to collect here within the well. And then you tap it off. Disadvantages is that they're shallow and they can dry quickly when there's periods of droughts because they're not very deep. They don't hold a lot of water. Other problems is that they are subject to contamination. So if you have a fuel spill or other products on top of the ground that are not well, like think of if you were next to a pile of manure or a farm or something like that. Like that wouldn't be a good idea. You wouldn't have your water supply next to a source of contamination, say a manure pile. Like those things, those contaminants, the bacteria can make their way into your water supply. So you have to be very careful of that. This water should be tested regularly. Driven wells are constructed by driving a pipe into the ground. So next step up from digging a well, is so you get a machine to hammer a pipe into the ground. So they're simple, pretty cheap to construct, but they can only go so deep, and they're not sealed with grading material. In other words, they're not sealed. You're still subject to contamination. And they usually go about 30 feet deep, could go up to 50. So if you look here will be a dug well. Person's down the hole, and tonight a driven well. You use a driver machine to drive the pipe into the ground, or you can use a drilled well. And another, so drilled wells, usually you're looking for, you call them artesian wells. So you're looking for, think of like an underground pond. So you can have an underground water supply that is continuously fed by rainwater, but it's a large reserve of water. Artesian wells, what people are going to look for when they have a rural water supply. So when you're again your cabin or you're not on a main water system, you're going to try and dig an artesian well. A bored well is done with an earth auger. So, well, if you've seen an ice auger for going ice fishing, well, you can have one for earth. So similar idea. So you have a boring, be it a shaft, and you're digging down through until you strike water. So let's talk about where your water comes from for a moment. So possible plumbing sources. So you can have groundwater, so the rain will come down, and then you have groundwater. So the water will only go so deep, and you could tap into that groundwater by digging a well. The reason why the water usually don't go so deep is because you have bedrock beneath the water, a certain level through which the water can't pass anymore. The ground will be too hard. That rainwater could also lead to surface water, so lakes and ponds. They can be a source of water for you. And then last example would be if you had a dug well. If you had a dam. And familiar with dams, I mean, there's a dam in Fortune, there's a dam in Grand Bank themselves, and so they're not uncommon. All right, that takes care of this section of notes. Thank you.